So we've already talked about average atomic mass, how it's calculated, where to find it on your periodic table, and how it's measured. We talked about mass spectrometry. So if you guys will go ahead and get this down, and then we'll talk about it. Okay, so molar mass is numerically the same as average atomic mass. So find lithium on your periodic table. What's lithium's symbol? Li. Li. So find lithium. What is the average atomic mass of lithium? 6.94. That's they're different. We're going to use your periodic table that you have printed off.
Oh, yeah, come on. Okay,
so what we are going to use that molar mass as is numerically the same as average atomic mass, but the unit is grams per mole. So the molar mass of lithium is 6.94 grams per 1 mole. So that's what's written out here. We can write it like this. It is also a conversion factor, right? It's a ratio. So we can say 1 mole of lithium occupies a mass of 6.94 grams. So now our second conversion factor is going to allow us to go between moles of a substance and grams. So ultimately, we're going to be able to go between mass in grams and number of particles, right? By way of our new favorite thing, the mole. We're going to have to use Avogadro's number, yes. So what I want you guys to do is find the molar mass using your periodic table of sulfur, gold, lead, and tin. So this is not necessarily density, right? So we looked at iron, copper, and zinc. They're pretty close together in mass, but but we'd have to look at their volume to find the density. So go compare copper to iron. Did I?
Iron's not here.
Fe. That end one's Fe. That's zinc, which has a higher molar mass, but it's less dense. The atoms are less densely packed together. Between the
Wait, so you're telling me that's atoms right there?
they're atoms, yeah.
That's so weird.
Everything that is matter is atoms.
Oh, I'm atoms?
You are.
Whoa. Wait.
Are those two the same size? The two, I can't see them now.
Wait, these are the same size,
Okay.
but this one's heavier.
Yes.
The copper one's heavier.
So the copper one is copper is probably a little bit more dense than iron.
This is so weird. So
Yeah.
light.
Now wash your hands.
Yes, ma'am.
Okay. We can write average atomic masses or molar masses as conversion factors. So if we look up the molar mass of copper, it's 12.01. And so 1 mole of copper atoms occupies a mass of 12.01 grams. Is occupies a mass? That's not the best wording, but yeah. So are we saying 1 atom of copper has a mass of 12 grams? No, 1 carbon. 1 mole of carbon has a mass of 12.01 grams. That would be how many atoms of copper? Carbon. If one 6.022 times 10 to the 23rd atoms of carbon would have a mass of 12.01 grams. So if you guys will write this down, and then we're going to jump into some problems if you want to. This is optional. It's just how you would set up the conversion factors. So what are we given? We're given moles of aluminum. So 3.00 moles. We want the number, all sig, the unit, and the substance. So when we talked about Avogadro's number, did it matter what the substance was? Did Avogadro's number change? No. Is molar mass going to change depending on our substance? Yes. So we need to find who on our periodic table.
Who? Aluminum?
What? Aluminum.
Oh, I was like, who?
Sometimes they'll start to feel like people with as much as we use them, but they're not. You're right. I should not. And what is that word for making? It doesn't matter. This is an English class.
1 mole, do 1 mole, and then you put 6.022.
That's going to give me atoms of aluminum. But I want grams.
Oh, so 1 mole, and then 26.98 grams to the mole. Like divided by gram. Just gram.
Right? Molar mass is grams per 1 mole. So the molar mass of aluminum, where do we find that 0.98? On the periodic table. We can write it as 26.98 grams over 1 mole, or 1 mole over 26.98 grams. Why did we write it this way?
So you can cancel off the mole.
What's they? Well, moles cancel out. I don't actually know who they was in your completed statement.
Well, what did I say?
I don't know. So they can, you said so they can cancel out moles.
I thought I said same. I thought I said you. My bad.
Okay, and that's all I need to do to get to grams, right?
Yeah.
So how many significant figures should my answer have?
3.
3, very good. So, what do we get? Tippity type it in. This is easier tippity typing.
I'm confused on what math point goes on.
Okay, these are just, go ahead.
Oh, I was gonna say it's 26.98 times 3.
Yes, these are just fractions. So, start,
the same with the other.
yes. So these are just a way to keep fractions neat together. So there's different ways you can work it out. You can multiply the entire tops, multiply the entire bottom, and then divide. Or my favorite way to do it, so I don't have to get to the answers. Start here, multiply by the numerator, divide by the denominator. Multiply by numerator, divide by denominator. You
But
can
if, all right, so once we multiply those, do we divide by the 1 mole?
Yes. Which, pardon? It's the same, yeah, you wouldn't have to, but yes, when you're learning the process, it may help to talk through each part of it, just to, you know.
Yeah, because
Yeah. Good.
It's 80.9.
Very good.
Please don't round it up.
We should get, yes. Very good. You guys want to try B,
because,
and then,
oh.
you guys try B, we're gonna go over it, but I think based on how easily you guys put that together, the fact that you're looking at like where you
Alright, since, like, there's 0.02 missing, like, like away from 27. I knew I would just have to 27, and I just subtract 0.06 and make my answer.
That's so weird.
Because 3 times 27 is 81. Thanks.
But it's okay.
I figured it out because 3 and 27 are both divisible by 9. So, I'm not divisible, but like they go into 9. Figured it out. I don't know. Oh yeah, because
talking is what you're doing.
That's a surprise. You're
I
never
think
gonna stop
I
by
need to go to a doctor and see if I might have like ADHD or something.
I think you're just tired and probably trying to keep yourself awake.
I think that's what I'm doing. I think I need to go to a doctor and get something to help me stop
Okay.
talking.
I have AED. So.
Okay, what are we gonna do here? We've got grams of neon and we want to find moles. So what allows us to go between grams and moles?
Oh, so you need
Molar mass, right? That's our conversion factor. So we need to find neon on our periodic table. What's the molar mass of neon?
20.18.
Okay, where am I gonna put that?
well, so you cancel that.
Good. So I'm gonna put 20.18 on the bottom. It's equal to 1 mole of neon. So 1 mole of neon goes on the top. And you guys set it up that way so that grams cancel out. Now, typing this into our calculator, start at the beginning. So 13.9 times 1, you don't have to type it in, divided by 20.1. This is just a fraction, right?
Wait, so who?
This times this right here.
You just multiply across.
You can do that. You can multiply across the top, multiply across the bottom, and divide. I personally like to just plug it all in at one time. For me, but
Yeah, just treat the right side as like a fraction, though.
it is not like a fraction. It is a fraction.
Yeah.
And it's equal to 1.
So if one's over, you divide. One's on the bottom, you multiply. The other one is not.
Mm-hmm. How many significant figures should we have?
3.
Okay, so what do we get?
0.69.
That's 8, 9.
Oh, yeah, 0. I forgot about that.
And that's moles of neon. Very good. Let's do C together. How many moles of electrons and protons are contained in 5.7 grams of lithium? Okay. Be careful. Does this ask us for the number of protons and electrons?
So how many moles?
It asks us for moles of protons and electrons. Okay. So we're given grams of lithium. We're going to have to get to moles of lithium. So how will we go from grams of lithium to moles of lithium? Mm-hmm. So 1 mole of lithium has a mass of 6.9 grams. Okay. So if I stopped here, I would have moles of lithium. Is that something I can be asked about? Yes, absolutely. But this problem is asking me about moles of electrons and protons. So if I find lithium on my periodic table, 1 atom of lithium has how many protons?
3.
Bear with me through right a lot. Can 3 and 3 electrons. So 1 atom of lithium contains 3 electrons. So you could also say 1 atom of lithium contains 6 protons. 3 plus 3 is 6. For this problem, we're trying to find moles. So let's go back to that students. If I have 12 dozen students, no, if I have 1 dozen students, how many dozen fingers are in that room?
Oh, Lord.
Dozen. 10 dozen fingers are in the room. So I could talk about 12 students and 120 fingers, right? Or 1 dozen students and 10 dozen fingers. They're the same thing. So when we talk about subatomic particles or parts, we can also say 1 mole of lithium contains 6 moles of protons and electrons.
So you just multiply with 6.022 times 6, and then you change.
By writing this way, we would divide both of taking this conversion factor, the 1 atom is 6 protons and electrons, the actual number. We would divide both of those numbers by Avogadro's number. So we divide them both by the same thing. So we can just skip that and say that 1 mole would be 6 moles
so
of
now
protons
we
and
know
electrons.
We can put the 1 mole lithium on the bottom and put 6 mole. Well, I mean, we can put 6 mole of protons and electrons
On the,
bottom,
no,
on top,
top.
and 1 mole.
You could go moles of lithium to atoms of lithium using Avogadro's number, right? Then atoms of lithium to number of protons and electrons by multiplying by 6. But then what would you need to do to get back to moles of protons and electrons? Divide by Avogadro's number. So you would multiply by Avogadro's number, then multiply by 6, then divide by Avogadro's number again. So what I'm saying is you cannot do that. You don't have to do that. You can say, just like if we have 1 dozen students, we'd have 12 dozen or 2 dozen eyeballs. If you have 1 mole of a substance, you can count the moles of subatomic particles. So 1 mole of lithium would contain 3 moles of protons and 3 moles of electrons.
Yeah, we don't have to convert it to the 5.7 grams.
Why are you packing up? We still have 8 minutes.
I'm not, I'm picking this up. I'm learning, I promise.
Do you want me to show you the way where we don't use this condensed? Okay. If my eraser will work. Okay, so we would go mole of lithium to atoms of lithium. 6.2 times the third atoms of lithium is 1 mole. Then I would use the 1 atom of lithium contains protons and electrons. That we've already done. If I stopped here, though, I would have the total number of protons and electrons. But I want the moles of protons and electrons. So then I would need to divide by Avogadro's number again. So 1 mole of protons and electrons is equal to 6.2 times 10 to the 23rd protons. So do you see how I multiply by Avogadro's number and then would divide by it? I can just say 1 mole is equal to moles of whatever you're counting. You don't have to, because if you don't remember that relationship, or right now something that feels concrete enough, it's not going to cost you any more than 30 seconds to multiply by Avogadro's number and divide by it. You should do it the way that makes the most sense to you. Okay? So, what do we get? Good. I got 4.9. Did I type? Yep, I typed it in wrong. 4.97 moles of protons and electrons. Okay, we will stop here for today.